Okay, definition 2.1. A permutations, okay, is an arrangement of all of part of a set of object. Oh, what is it? So now we refer to example 2.16. Consider the three letters A, B, C. So you have three a letter in your hand. Okay, what is the total arrangements you can arrange for when to arrange these three letters? So imagine that A, B, C is in your hand now. You're holding three letters in your hand. You go to the first box. There are three boxes in front of you. So when you go to the first box, then you still have three letters in your hands. How many ways you can put one letter down into the box? There are three ways. Then you put one, can be A, can be B, can be C, doesn't matter. Then you go to the second box, but at the time when you come to the second box, you only have two choices. So you can have put and one of them. So when you go to the third choice, third boxes, then third box, you only have one. So what is the total arrangement? The answer is 3 multiplied 2 multiplied with 1. So that's why we say 3 factorial. Uh, this can be illustrated by drawing the probability tree. So this is permutations. So now, okay, example 2.16. The motor car engine number consists of three letters F, G, H, followed by 5-digit 1, 2, 3, 4, 5, 3, 4, 5. Find the number of possible password. Okay, we assume that letters is letters, digit is digit. They arrange them by themselves within a group, but they never mix. So what is the number of way for you to arrange three letters? So since 3, so that's why it's 3 factorial. Okay, how about 5 digit is 5 factorial. So that's why 3 multiplied by 5 equal to the total way for you to arrange 3 letters and 5 digit in different ways. Okay, so remember we use in this case because of n, that's why we multiplied them. 3 factorial multiplied with 5 factorial is equal to 720. Okay, so now okay we come to theorem 2.3. In the previous one, okay, we have three objects. How many ways for us to arrange them? Is 3, 2, 1. But sometimes it's not necessary we have to choose all of them, to use all of them. We just want to use part of them, for example. Like example 2.17. Consider the four letter A, B, C, D. What is the number of combinations that are possibly by taking two letters at a time from 4? So means that you have 4. So we only get 3. Sorry, get 2 letters. How many ways for you to arrange them? So you can imagine that you have 4 letters in your hands, but in front of you there are only 2 boxes. So when you come to the first box, how many ways for you to put one letter into the box? Is 4 ways. When you come to the second one, there is only 3 ways. The other two is because of it's not selected. That's why okay they are not take into consideration. So in general, okay, before we go to the okay, now the answer is 12. We can list down how can we get 12. So A, B, A, C, A, D, you can see there are different arrangement. So this is equal to 12. The in general is okay, we can say n minus 1, n minus 2, and we stop at n minus r plus 1. N is, if you refer to example 4, 2.17, n is 4, r is the object we want, only 2. So 4 minus 2 is 2 plus 1. So that's why it's 3. So 4 multiplied with 3. So this is the general way for us to write the equations. So can be written okay, in the other form is equal to n factorial divided by n minus r factorial. So n factorial is the number of a to arrange all items. N minus r is selected, n is total. So n total minus selected is representing unselected object. So we discounted them because of we don't care how they are going to arrange by themselves because of they are not selected. So that's why in short we also can write the equation according to equation shown in 2.4. So now okay we have example 2.18. How many different ways are there to select bus driver and the co-bus driver from a group of 10? So you have 10 persons, but you only have 2 positions. So you can imagine that there are 2 boxes. First box is for you to select one person and put the person into the box 1 as a driver. Second box representing co-drivers. So when you come to first drivers, 10 choices. You can put one of them into there are 10 choices. But when you come to the second one is 9 choices. 10 multiplied with 9 you equal to 90. So you also can use example theorem 2.4 equations. 10 factorials, 10 minus 2 factorials is the A persons which are not selected. When they are not selected, how do they arrange themselves is not interested. That's why you will get equal value which is equal to 90. Okay. In 1 year, 3 awards will be given for a group of 25 truck drivers in the insurance company. If each truck driver can receive at most 1 award, how many possible ways selections are there? So there are 3 awards, but you have 25. 3 are the boxes. You have 25. So it's 25 multiplied with 24 multiplied with 23. So either you think this way or you use the equations, you will get the answer which is 1388. But I prefer you to write 25 multiplied with 24 multiplied with 23 because I can understand, can read your mind of thinking. So if I change the answer, the question say there are 3 awards, but the same person can get more than one. So can get 1, can get 2, can 3. So what is the answer? The answer is 25 multiplied with 25 multiplied with 25. So the answer is different. So when I change this, then this, if you write 25, 25, 25, multiply all of them, 3 of them, then we can understand how do you think. Okay, so now we come to example 2.20. So a bus driver and an assistant bus driver are to be chosen from 50 drivers. How many different choices of officer are possible if there are A, B, C, and D? Okay, A is the simplest, the total number of choices. There is no restrictions. So the answer is first position 50, one second position is 49. So the total is 2450. Okay, B, since A will only serve if he is the driver, sorry, if he is the driver. So A said that if you want to employ me, I must be the driver. So what is the what is the answer? The answer, there are 2 scenarios. The first scenario is A is selected as a driver. So we only have 49 choices for co-drivers, 49. So we keep the value first. Okay, second is, since A is so ego, I don't want to employ him to be a driver or co-driver. So then he will be excluded. So 50 reduce 1 become 49. So how many way for you to choose 2 out of 49 to replace them as the driver and the co-drivers? So the answer is 48 multiplied by 49. So the value is equal to 2352. So 49 plus 2352, you get 49. Okay, and number C, the numbers of sections when B and C serve together. So means that if you want to employ, we have to be together. So if you listen to the suggestion, you say yes, I am employee of you two. So B and C, but B and C, they have 2 positions, different positions. That's why the number of way to choose them to fill in 2 position is 2. B is a driver, C is a co-driver, or C is a driver, B is a co-driver. But we also can say that, okay, we don't want this to be happen in our company, so I exclude 2 of you. So means that we only have 48 left. So 1 is the number of way to choose 2 out of the 42. So it's 42 P2. So then you add up these 2 values, then you get the answer is equal to 2258. Number D, there are 2. D and E cannot work together. So the number of sections when D serve as a drivers but not E. So the answer is 2 multiplied with 48. So 2 is the number of D position D can take. 48 is the number of selections of the other officer from the remainings. Because of, if you say D is considered, so means that E is not considered. So means that we only have 48. Apart from E, we only have 48. So the answer is 96. But we also have another case is uh, uh, E will serve but D will not serve. Then the answer is the same, is also equal to 96. So that's why when you see this, okay, we have 2 multiplied with the 96 means that 96 there are 2 different scenarios. One is E, the other one is E. Okay, one is D, the other one is E. So but okay, we also have the number of selection when both D and E are not chosen. Okay, so the first scenario is either one of them is chosen, but we can say that we don't want them. So many troubles, we don't want them. So when we say we don't want them, we only have 48 left. So out of the 48, we want to choose 2. How many ways for them for us to choose 2 to place them as a driver and a co-driver? The answer is 2256. So that's why the answer is 2 multiplied with 96 plus 2256. Then we will get the answer which is equal to 4448. We also can use another way. Okay, if you still remember that in part A, there is no restrictions. We just said that 50 people, we want to fill 2 positions. So what is the number of way? So we say the number of way is 2450. But we use the complement rule. Okay, 2450 is everything. Now we minus. How about if D and E say they can work together? If they can do work together, there are only 2 ways. D become the driver, E is co-driver, or E is the driver, D is co-driver. So there are 2 ways. So we just minus them out, then we will get the answer which is also equal to 2448.